So let's do another example involving logical equivalence. Let's show that the statement forms not P and Q and the statement form not P and not Q are not logically equivalent. So here we want to show that they're not logically equivalent. So when we look in the truth table, the columns should not match up. They should not be the same. So let's see. If I look at my two pieces I have here, my two statement forms, I have two variables. I have P, I also have Q. So I'm going to need 4 rows in my truth table. True, 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 false, false, true, false, false. And so we're going to start by making the pieces that we need. For the second statement form, we're going to need not P. We're also going to need not Q. So take and flip the P column. Flip the Q column. For the first one, we're also going to need P and Q. So we're going to write down that column, true, false, false, false. And now we're ready to make our two pieces. So for the first statement form, we need not P and Q. So we're going to flip that last column, false, true, true, true. And then we also need the second statement form, which was not P and not Q. So you're going to look at the not P and the not Q column and put an and between them. So remember, for an and, they both need to be true. So I get false, 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 true. So now we're going to look at just the last two columns here. These are my two statement forms. And we want to show that they're not logically equivalent. So we need a row where the two columns don't match up. Here we actually have 2 rows where they don't match up, the second and the third row. So these two statement forms, they don't have the same columns, so they're not logically equivalent. So in these 2 rows, I can say that they have not the same truth values. So what we're going to do now is take and look at this a little bit more. So let's see. I had P, I had Q. So maybe we're looking at something different than the last example, but we're going to build off of this truth table that we already have. And so we had, take that first statement form, not P and Q. It was false, true, true, true. And now let's see what we get. Instead of doing not P and not Q, let's do not P or not Q. So looking back, you're going to look at these 2 columns here in your original table, and now you're going to put an or between them. So the first row, you get false. Then you'll get true, true, and true. And now the columns match up. These 2 are the same, which means they are logically equivalent. So I can say that not P and Q is logically equivalent to not P or not Q. There's another version similar to this, and I'll say you can also show through truth tables that when you negate not P or Q, this is logically equivalent to not P and not Q. So these two things that I've boxed in here, these are called De Morgan's laws. And it basically tells you how to distribute a negation. So when you do like this one, when you negate P and Q, you distribute the negation across, but then the and that you had before becomes an or. Same thing for this other one. When you distribute a negation, a not symbol, you distribute it out, but then you're going to switch the or. It's going to become an and. Okay. So let's look at an example using De Morgan's law. Use De Morgan's laws to write the negation of the inequality -1 is less than x is less than or equal to 4. So remember, we saw these inequalities before, and ones like this are an and. So let's rewrite it with an and in it. -1 is less than x, and x is less than or equal to 4. And now we want to negate that using De Morgan's law. So, using De Morgan's law, the negation is, so if I negate it, you're going to start by negating each piece, doing the opposite of it. So that means you're going to change the inequality. The opposite of -1 is less than x, is -1 is greater than or equal to x. And then you're going to negate the other one. X is less than or equal to 4. The opposite of that means x is greater than 4. And then the last thing you have to do is you have to negate, switch the and. It becomes an or statement. So this would be the negation. You can also see, if you think about these in terms of graphs, you can see the negation as well. So here, if I graph this inequality that we started with, we don't include -1, we do include 4, and then everything in the middle. When you negate that, what you do is you flip the circles. So you're going to fill in the circle at -1, but leave it open. And then you're going to shade in the other part of the region. So not in the middle, you're going to shade the opposite, the outside. And if you wrote that down as an inequality, that would be exactly what we have written here. Okay.